An oil rig capsizes, sending 84 men to their frigid, watery graves. A jet fuel plant explodes, raining devastation for miles around. A pro golf star's plane goes down, shrouded in mystery. 4 vehicles plunge into a river as a bridge collapses in the darkness of night. And the worst dam failure of the 19th century annihilates an entire town. Now, engineering disasters on Modern Marvels. Just 10 miles outside the city of Las Vegas lies the suburb of Henderson, Nevada. On May 4th, 1988, this small community changed forever. 3 miles from town, 2 major explosions measuring 3.0 and 3.5 on the Richter scale ripped through the desert locale and sent visible shockwaves across a 10-mile radius. 2 people died. Over 300 people in the surrounding area were injured. Property damage was nearly $100 million. The 2 explosions originated at the Pacific Engineering Production Company of Nevada, otherwise known as PEPCON. PEPCON was one of only 2 U.S. manufacturers of ammonium perchlorate, an oxidizer for solid rocket fuel.
AP, or the long name is ammonium perchlorate, is a salt. It's comprised of ammonium, which is nitrogen and hydrogen, and chlorate, which is comprised of chlorine and oxygen.
This odorless white granular substance is not volatile if left alone. However, it becomes highly explosive if contaminated or combined with any kind of fuel.
To give you some perspective, ammonium perchlorate, which is 55% by weight oxygen, as compared to the air we breathe, which is only approximately 29% by weight oxygen. So it's richer in oxygen and therefore promotes combustion of most fuels more intensely.
Ammonium perchlorate is used on a large scale in solid fuel rocket engines for NASA and the military. It's the chemical in rocket propellant that releases oxygen, essential in the combustion of fuel. One of the biggest customers for AP is NASA's Space Shuttle program. On January 28, 1986, the Space Shuttle Challenger exploded 73 seconds after takeoff, causing NASA to ground all Space Shuttle flights. But PEPCON continued to manufacture ammonium perchlorate and stockpile it. Never before had so much ammonium perchlorate been stored in one location.
We had approximately 10.5 million pounds of ammonium perchlorate being stored at the PEPCON facility. PEPCON was multiple buildings occupying approximately 15 acres. The buildings were typically constructed of fiberglass reinforced plastic panels over metal purlins and beams and posts. This was done because of the nature of perchlorate being so corrosive.
On the morning of May 4th, 1988, an open barrel of AP caught fire.
It's our observation that the plant housekeeping was not very good. There's a very strong possibility that much of the ammonium perchlorate on site had some very low level of contamination.
The fire from the one barrel rapidly spread to other storage containers and the fiberglass structure itself. The only tool that workers had to combat the fire was a garden hose. It was ineffectual.
With a class 4 oxidizer, such as ammonium perchlorate, there is no real method of fire extinguishment. Once it gets going, you can't put enough water on it quickly enough to break the combustion chain. The employees at PEPCON, our analysis showed and follow-up investigation showed that the safety briefings that they had basically included, if there's a fire in the plant, run like hell.
With wind blowing, the fire quickly became a raging inferno.
When subjected to heat, the AP started releasing its energy, goes into a self-heating process. It's releasing copious amounts of oxygen, and it reaches what's called critical mass.
At just a few hundred degrees, AP can begin to consume itself, acting as its own oxidizer and fuel. A chain reaction began. The plant was being engulfed by fire. Polyethylene drums launched like rockets into other nearby storage areas and ignited more AP.
Detonation is a high-speed explosion as opposed to just a fire or a deflagration, which is a low-speed explosion. What we had at PEPCON was a detonation because it caused that final shock wave.
The fire burned for approximately 20 minutes, generating tremendous amounts of heat before the explosion that caused the first shock wave.
Ooh, that's going to be loud.
It basically proceeded through the storage of ammonium perchlorate very much like a Roman candle. And then this very rapid heating and thermal shock caused the ammonium perchlorate to explode.
A total of 7 explosions occurred. Firefighters rushing to the scene were caught in the shockwave and reassessed their adversary.
As we were driving down Boulder Highway, I had the window open, and one of the other explosions that occurred, I could actually feel it hit me. Not that it did any damage, but I could feel the vibration of the explosion.
To exacerbate an already critical situation, a natural gas pipeline ran directly under the plant.
The final detonation, which measured about 3.5 on the Richter scale, occurred right over the gas line. It was a 16-inch gas line servicing the city of Las Vegas, Nevada.
Having consumed its fuel of AP, the initial fire burned itself out, but the ruptured pipeline fed a new 100-foot plume of fire. It burned for almost an hour before the line was shut down.
There was a lot of speculation in the early part of the investigation that the pipeline may have played a role in at least initiating or aiding and abetting those explosions.
It took months of investigation by teams of experts to determine the cause of the explosions.
We were retained to bring in the appropriate people with the right technologies to understand what went wrong and how it happened.
What investigators surmised was that welding debris had drifted through the air to an area of open barrels, igniting the AP.
What we found out was that there had been welding and what's called flame cutting activities on some of the steel structure in the batch dry building.
Open barrels of AP were common in certain areas of the plant, but that meant they were exposed to dust, fibers, and other contaminants, creating the perfect tinder. The storage containers that held the AP also contributed to the intense heat and combustion.
They chose to store the ammonium perchlorate in several different kinds of containers. One container they used was what we call an aluminum tote bin. Another container used was what we call poly bins, and it's like a smaller 55-gallon drum. Those two types of containers were the majority of the containers. Now, the irony of the situation is that one of the standard formulas for a solid rocket propellant is approximately 70% by weight ammonium perchlorate, 15% by weight aluminum particles, and 15% by weight rubber binder.
The polyethylene drums provided the rubber binder, and the other bins provided the aluminum fuel.
And when that's all mixed together, it makes a solid propellant.
After investigators examined the evidence left at the scene and conducted various experiments with ammonium perchlorate, the reason for the explosions became clear.
The question was, how can ammonium perchlorate detonate? The answer is, it can detonate when it's heated, and very definitely it was heated intensely by the precursor fires here. Those fires being particularly intense because they were fueled by ammonium perchlorate acting as an oxidizer.
The PEPCON catastrophe demonstrated the extreme importance of proper AP storage.
I think there's a lot of things that we learned after the disaster, and certainly the most important is a safety culture within the organization that's manufacturing these types of chemicals. And remember that this stuff was basically stored out in the parking lot.
Many thousands of pounds of it stored in close proximity. And we know for any kind of substance that's potentially explosive that that's bad practice, that instead small amounts should be stored and compartmentalized with cement walls or something, such that if one area does ignite and go, it's not going to sympathetically detonate all of the rest.
Pacific Engineering Company of Nevada has since changed its name to Western Electrochemical and is relocated to an even more remote location. However, now it is the sole manufacturer of AP in North America. The AP explosion, measuring magnitude 3.5 on the Richter scale, equaled the energy yield of over 300 tons of TNT. Engineering disasters will return on Modern Marvels. Each day, about 90,000 vehicles travel Interstate 95 between Connecticut and New York. But on June 28, 1983, 4 such vehicles wouldn't make it home. At 1:28 a.m., a 100-foot section of a Connecticut Turnpike bridge collapsed, sending 2 cars and 2 tractor-trailers plummeting 70 feet into the Mianus River below.
The first truck immediately locked up its brakes. That was the one in the right lane, and started skidding about 150 feet before the beginning of the structure. At that point, the person following did in fact slam on their brakes also, fearing an accident because of the jackknifing trucks in front of them, at which point 3 vehicles disappeared from sight.
I reached the site and I looked over the edge and I thought I was in some sort of a science fiction movie. There was lights all over the place, police lights, sirens, and I looked over the bridge and there were 2 trucks dangling in the water. There was debris from the bridge and there was all kinds of debris from the trucks. And the first thought in my mind was that only 4 cars fell over.
Lives had been lost, and a major artery in the transportation system was now severed. I-95 was closed in both directions as National Guard helicopters helped police reroute traffic. State and federal agencies, as well as private engineering firms, were called in to investigate the accident that devastated the affluent community of Greenwich, Connecticut. An oil rig capsizes, sending 84 men to their frigid, watery graves. A jet fuel plant explodes, raining devastation for miles around. A pro golf star's plane goes down, shrouded in mystery. 4 vehicles plunge into a river as a bridge collapses in the darkness of night. And the worst dam failure of the 19th century annihilates an entire town. Now, engineering disasters on Modern Marvels. Just 10 miles outside the city of Las Vegas lies the suburb of Henderson, Nevada. On May 4th, 1988, this small community changed forever. 3 miles from town, 2 major explosions measuring 3.0 and 3.5 on the Richter scale ripped through the desert locale and sent visible shockwaves across a 10-mile radius. 2 people died. Over 300 people in the surrounding area were injured.
Tidal flow from the Long Island Sound, but also the material that we put on the roads in the winter has quite a bit of salt in it. And over a course of years, recognizing this is now 30 years old practically, rust built up.
The official statement from investigating engineers was that the Mianus River Bridge collapsed because of undetected lateral displacement of the hangars by corrosion-induced forces. The rust caused the inside hanger of the northeast corner of the suspended span to slide off the lower pin. Now the entire weight of the span's north end rested precariously on one hangar assembly. Because it wasn't designed to carry this much weight, it was only a matter of time before it too failed.
And then ultimately, the pin worked its way out of the remaining hangar, and that corner of the span fell.
While rust corrosion of steel subjected to this type of environment is essentially a natural, unavoidable process, the undetected part was definitely avoidable. Hardesty in Hanover was one of the engineering firms called in to evaluate the collapse.
After looking at the situation, we knew that the other three spans were in immediate danger. And by noon the next day, we had a mechanism to clamp the remaining pin and hangers together so that they would resist failure.
A temporary bridge span was installed 25 days after the accident, allowing traffic to resume. And construction began on a more permanent structure, which opened in January of 1984. But with so many of the state's bridges built with the same failed technique, the race to prevent more potentially fatal bridge collapses was on.
Subsequent to the Mianus River event, not only the state of Connecticut, but the entire country went out and started inspecting all their pin and hanger assemblies. We inspected all the hanger assemblies, cleaned all the hanger assemblies, upgraded the hanger assemblies to be certain that they had the appropriate connection pieces, and then we put in what we call catcher mitts, a structural component beneath the hanger that if the hanger does in fact fail, that end of the structure can't fall.
The accident drew national attention to the problems caused by deferred bridge maintenance. Connecticut's Governor William O'Neill embarked on an unprecedented 10-year, $5.5 billion plan to reconstruct and rehabilitate the state's roads and bridges. In 1989, the Mianus Bridge was transformed again, with expanded traffic lanes and updated retrofitting. Thanks to Governor O'Neill's dedication, Connecticut now boasts the nation's best bridge inspection and maintenance program. Perhaps the bridge designers of the 1950s didn't anticipate that future generations would neglect maintenance. But the 3 lives taken by the failure of the Mianus River Bridge may have saved many more. In 1983, the Mianus River Bridge was secured and rebuilt at a cost of over $75 million. Engineering disasters will return on Modern Marvels. Tumultuous storms in the North Atlantic are not uncommon. But the Ocean Ranger was built to withstand the worst of them. Owned by Ocean Drilling and Exploration Company, or ODECO, it was hailed as unsinkable. The $120 million semi-submersible oil rig was the pride of an offshore exploration fleet. Its job was to search for oil farther and deeper than ever before, in areas previously thought too hostile.
A semi-submersible is a particular type of vessel that's really been adapted exclusively for drilling offshore. And the reason for that is it's got particularly good motion characteristics in waves. And that is achieved by having the pontoons underneath the water. The main part of the buoyancy is underneath the surface, and the part that crosses the surface are the columns, which are relatively small in area. And what this means is that the vessel doesn't respond to wave action very much, and so the motion characteristics are good for drilling.
With a platform the size of 2 football fields and towering 35 stories from keel to derrick, it was the symbol of stability.
The Ocean Ranger at the time it was built was the largest such vessel in the world. It had 2 pontoons and 8 columns, which was not unusual, but it was the largest vessel. And generally, with vessels, the larger they are, the better they behave in the sea. So it was probably the most tolerant vessel of its time. And of course, at the time, it was probably the most modern.
In November 1980, the Ocean Ranger arrived on the Grand Banks, 170 miles off the coast of Newfoundland.
Yeah, back in the 80s, and when work wasn't so plenty, you know, when the oil rigs came to Newfoundland, it was great. I mean, people got jobs offshore and they went out there and they made good money, and it was good work. The oil business in Newfoundland put a lot of people on their feet.
On February 6, 1982, the crew of the Ocean Ranger got its first scare when a problem with the ballast control caused the rig to tilt or list unexpectedly. Ballast control is the process by which the rig is kept level by pumping seawater into or out of the ballast tanks located in the pontoons.
I was in the crane moving around some stuff, and the rig started to list, so we didn't know what in the hell was going on there. So I got down out of the crane, and my workers and myself and all the other people went to the lifeboats, and it was kind of panicking because we didn't know. It was a beautiful day, and if it had to be a bad day that day, I wouldn't want to be aboard that rig.
Luckily, the seas were calm, and the problem was corrected, but the stage for catastrophe was set. John Crow went on his monthly shore leave a few days later. On February 14, 1982, an intense storm hit the Grand Banks with winds of 90 knots and waves as high as 50 feet. At about 8 p.m., a violent wave broke through a porthole in the ballast control room and washed over the control panel, causing the system to short circuit.
Now you have a whole bunch of electric components that are soaking wet with not just water, salt water. So of course, immediately the whole electrical system controlling the stability of the Ocean Ranger falls apart. I mean, stops working, starts working aberrantly.
Because such emergency situations were never anticipated on the unsinkable Ocean Ranger, technical and safety training had been less than adequate. The confused crew scrambled to fix the problem, but this time the seas were raging. Seawater entered the forward tanks in the port pontoon and caused a rapid 10-degree list to port and forward. The rig wasn't designed to deal with this kind of situation.
Where they had difficulties because on the Ocean Ranger the ballast pumps were located in the stern, it was listed to the bow. These pumps were not capable of pumping out the bow tanks.
The crew was also untrained in the operation of the pneumatic manual override system.
No one on that ship knew how to use extra long threaded control rods which would bypass the control panel that was now soaked altogether and could cause them to manually turn on the air relays that would change the valving and the stability of the ship.
Just after 1 a.m. on February 15th, a distress call was issued.
Search and rescue, Burns. Mobile radio calling? Yeah. Got an emergency on the Ocean Ranger? Yeah.
Half an hour later, the crew commenced evacuation.
And they want to evacuate by the looks of it.
But only a fraction of the men were able to board the lifeboats, which weren't even designed for violent storms and heavy listing situations. These circumstances had not been anticipated.
The launch method where you just drop them on two cables, you really have very little control over what happens as soon as you start that launch.
The rig capsized at 3:15 a.m. A nearby supply ship attempted to carry out rescue operations, but the seas were too rough and too cold. Wearing only their clothes and life jackets, the men, including those who fell out of the lifeboats, were immobilized almost instantly and couldn't grasp the lines being cast. All 84 of the Ocean Ranger's men met their watery graves in a matter of minutes. With no survivors, Canadian and U.S. investigators had to somehow piece together what happened that fateful night. Canada's National Research Council built a scale model of the Ocean Ranger and performed a myriad of lab tests to determine what went wrong.
This is the model of the Ocean Ranger that was used as part of the inquiry into the disaster conducted by the Royal Commission. This area here is where the ballast control room was located. The portholes would have been located so that you could see the draft marks. The water level would have been about here. And so you can see that the control room is located a fair ways below the main deck here.
The ballast control was located too low on the rig, and the control panel was too close to a porthole, rendering it vulnerable.
When you consider ballast control panels in rig designs that have been made since, it is almost universal, or I'm sure it is universal now, that if they are not waterproof, then they are in situations where either water from the outside or water from internal pipes cannot get at them.
Aside from identifying the design flaws, investigators cited inadequate crew training and numerous safety violations. As a result of the Ocean Ranger tragedy, survival suits, as well as technical and survival training, were made mandatory on rigs stationed in North Atlantic waters. Lifeboat launch systems have improved dramatically, and semi-submersibles are now required to carry lifeboats for 200% crew capacity, with half located on opposing poles of the vessel, in case of a heavy list in either direction.
On the Ocean Ranger, on that fatal night, I mean, I guess the weather was so bad, and I guess if they had to close the dark window in the leg, you know, so many things you can say they could have done probably, and I guess Mother Nature just let everybody know that you can't build anything big enough that she can take.
The Ocean Ranger weighed approximately 25,000 metric tons, about half the weight of the Titanic. Engineering disasters will return on Modern Marvels. Johnstown, Pennsylvania lies in the heart of the Allegheny Mountains. This 200-year-old town is a place of many stories, but the most famous and the most tragic is that of the Great Flood of 1889.
Well, Johnstown was a sort of backwoods trading center when it was founded in 1800. Boomed when the Pennsylvania Canal came through in the 1830s, and then 20 years later when the Pennsylvania Railroad came through. And it's a matter of decades. They've gone, you know, from kind of a frontier outpost to one of the leading steel centers in the world.
As industry grew, so did the town. Approximately 30,000 people resided in the area in 1889. Its location was a major reason for its success.
There are three major rivers around the Johnstown area. You have the Little Conemaugh River, and you have the Stony Creek River, and these two rivers merge to form the Conemaugh River itself. These rivers have provided what was necessary for the industries that were here, and these rivers helped put the town on the map.
The rivers also provided mass transportation and helped create the Pennsylvania Mainline Canal System.
By 1834, you had this wonderfully ambitious system that went basically from Pittsburgh to Philadelphia by a combination of narrow gauge railroad and traditional canals.
One problem with this system was a lack of water during the summer months. To ensure maximum mobility, the answer was to build a dam that would hold a reservoir of water to be channeled into the canals. The site chosen was 14 miles east of and 410 feet above Johnstown. Construction began on the South Fork Dam in 1838.
It was made of puddled earth, and what that means is they would just make a layer of earth, dirt and rock. Water would be added to make it airtight and watertight.
The center of the embankment consisted of slate, stones, and more earth. The downstream portion was built up mostly of rocks, weighing up to 10 tons.
It had, we believe, certainly one spillway, but we think it had a second emergency spillway. It had pipes running underneath it, a culvert that allowed the operator of the dam to actually drain it if there was an emergency.
Taking 14 years to complete, the dam stood 72 feet high, 918 feet across, 10 feet thick at the top, and 220 feet thick at its base. It seemed impenetrable.
But one of the many ironies in the timeline of the Johnstown flood story was that the western reservoir of the Pennsylvania Mainline Canal was finished just in time for canals to go out of business.
The railroads had taken over as the preferred source of transportation. With no need for a reservoir, the dam stood in neglect for the next 27 years. In 1862, a heavy storm caused a collapse in the center portion of the dam, which destroyed the stone culvert. The marred structure sat until 1879, when industrialist Benjamin Ruff bought the land and created the exclusive South Fork Fishing and Hunting Club.
Ruff, who had worked for the railroad, hired some workmen and came up here and began to rebuild the dam. They had no engineer working on the project, and it was really just a construction gang, a railroad construction gang.
Built like a railroad embankment, the dam was eventually repaired. But puddled clay was not used, and the culvert was not reinstalled. The old reservoir was now renamed Conemaugh Lake.
The South Fork Dam was really an accident waiting to happen. When it was reconstructed, there were several very serious engineering flaws, which really totally set the stage for disaster.
Along with no discharge system, one of the most damaging changes was the placement of mesh screens at the spillway, which prevented fish that had been imported for the club from escaping. The dam stood for close to another decade, until 1889.
The Great Storm of 1889 arrived. By the time people got up the next morning, on the morning of Friday, May 31st, many of the people in Johnstown saw that the streets in front of their homes were underwater. And it wasn't long before many of the streets in Johnstown actually resembled canals more than streets.
The rivers surrounding Johnstown were overflowing. Conemaugh Lake was taking on massive amounts of water in a very short period of time.
Conemaugh Lake would grow an estimated 30 to 33% larger than its normal size. Water was being dumped into the lake from the hills around it, as well as a lot of junk coming into the lake.
Frantic efforts to stop water from flowing over the top of the dam were futile. The spillway's mesh screens were so choked with debris, they couldn't be removed.
Water was rising about a foot an hour behind the dam, and it was just a matter of time until water started over the top.
Many railway travelers and residents of the towns that lined the Little Conemaugh River took to the hills. Those that didn't paid with their lives.
They stood watching till about 10 minutes after 3 when the eroded dam just pushed away and 20 million tons of water just leapt out of the reservoir and began a 14-mile descent on Johnstown.
The flood wave ripped through the valley, decimating everything in its path.
So what you almost had was a ball of water rolling down this narrow sluice-like valley, and it pushed ahead of it everything, trees, houses, boulders. It pushed 80-ton locomotives as far as a mile, snapped off 3-foot diameter hardwood trees.
Reportedly reaching heights of up to 50 feet, the wall hit downtown, severing buildings from their foundations.
And as the flood came into town, it broke into 3 directions, and you had 3 tidal waves come crashing into Johnstown.
Residents were floating on their rooftops, hoping for an escape. It took only 10 minutes for the town to be wiped out. The once bustling Johnstown, proudly built on the backs of hard labor, was annihilated. An estimated 30 acres of debris as deep as 40 feet accumulated at the stone railroad bridge on the edge of town. The wreckage contained coal, kerosene, and lime, which soon ignited and became a raging inferno.
The fire burned for 3.5 days, and as many as 80 people who survived the flood died in the funeral pyre at the stone bridge.
The death toll from the Johnstown flood is recorded as 2,209.
It was estimated about 20,000 were in areas that were actually hit by the flood, and so about 1 in 10 perished.
But the town itself did not perish.
The Johnstown flood started the first major civilian relief effort in American history. It's one of the most inspirational stories in American history.
A new organization called the American Red Cross, led by founder Clara Barton, was on the scene in 5 days. During the next 5 months, the Red Cross began its journey towards the organization we know today.
25,000 people were homeless. They all needed to be fed and clothed. And for weeks, people were dependent on commissaries, living in tents or hovels, constructed out of wreckage.
With remarkable speed, Johnstown began to rebuild. Within 6 weeks, the mills were back in operation. Industry and the railroads had made commitments to rebuild.
In Johnstown, their memorial was going to be a newer, bigger, better city.
Victims blamed the South Fork Fishing and Hunting Club, but the courts deemed the disaster an act of God. The survivors received no legal compensation. Today, the dam site is part of the Johnstown Flood National Memorial, run by the National Park Service. The area is once again used for recreation. But just 14 miles downriver, in the Grandview Cemetery, lie the bodies of 777 unidentified souls of the flood, victims of the dam's faulty engineering. The water from Conemaugh Lake took less than an hour to flow 14 miles down the narrow valley. The amount of water was estimated to equal that flowing over Niagara Falls in 36 minutes. Engineering disasters will return on Modern Marvels. Millions of people travel by air every day, most on large commercial airliners. Only a lucky handful can afford the luxury of private jet travel. But even the fortunate few can't always escape misfortune. On October 25th, 1999, champion pro golfer Payne Stewart, 3 other passengers, and 2 pilots boarded a Learjet 35 in Orlando, Florida. They were destined for Love Field in Dallas, Texas, the site of John F. Kennedy's final landing and the eventual swearing in of Lyndon B. Johnson.
The Lear 35 is a rather small twin-engine business jet. In this case, it was used for on-demand air taxi purposes. It's quite fast, cruising at an average airspeed of about 500 miles an hour. It's got long legs to it. You can go over 2,000 miles in one of these before you have to refuel.
The airplane in question that Payne Stewart was flying, I believe was built in 1976. It's been a very popular airplane, very reliable.
The planned flight time was 2 hours. The plane was filled to 5,300 pounds fuel weight, enough for a 4-hour, 45-minute flight. The aircraft departed at 9:19 a.m. Minutes later, something happened.
They received a clearance up to 23,000 feet at about 9:27, I believe. They acknowledged this particular transmission without any problems. There was nothing excited in the pilots' voices at all. And they began to climb higher. Later, they were cleared to 39,000 feet, and the air traffic controller, about 6 minutes after this last transmission, called them up again to ask them to rechannelize their radio and transfer to another air route traffic control center. Well, they got no response, and he tried about 5 more times, still didn't get a response.
The aircraft proceeded to climb an altitude and then deviated from its flight plan as it crossed into the central time zone.
And then when it finally climbed through its altitude, its assigned altitude, without leveling off, I'm sure they became quite worried, and alarms began going off across the country, in fact.
At 9:52 a.m., the FAA summoned Air Force chase planes. An F-16 caught up to the derelict aircraft, 45,000 feet over Memphis.
They noticed no gaping holes in the airplane, none of these windows blown out, for instance, no holes in the windscreen.
And no response from the target aircraft. As I mentioned, both sides of the cockpit are condensed or frosted over. Could not see in the cockpit area.
Based on what the pilots observed, it was likely that the cabin had depressurized, and the inhabitants were incapacitated, and quite probably dead. With no radio contact in over an hour, and no idea what was happening on board, all anyone could do was watch and wait for the Learjet to run out of fuel and crash.
The Air Force and the FAA really did not have a lot of options. Again, you have to remember this was well before 9/11, so there was undoubtedly no great concern about terrorism or anything like that. The aircraft was on a steady course over the vast Midwest stretches of this country. It wasn't going to overfly any large cities or anything, so the options were quite limited. The aircraft was escorted the entire way up north until the engines quit and it crashed.
NTSB investigators toured the twisted wreckage at the crash site near Aberdeen, South Dakota, over 1,000 miles from the flight's intended destination. The evidence indicated that the plane did indeed suffer a massive loss of cabin pressure.
Aircraft such as the Lear and airliners that people fly around in today are pressurized. That's because they fly so high that the air is too thin to sustain life, and the aircraft itself compresses air to put into the cockpit and the cabin. And again, people need compressed air, a lower atmospheric pressure to live, actually.
Outside air flows into the engine and passes through a compressor. The air is pumped through filters and then circulates throughout the cabin. An outflow valve at the back of the plane lets some of the air out so that a cabin pressure of about 6,000 feet can be maintained. An oil rig capsizes, sending 84 men to their frigid, watery graves. A jet fuel plant explodes, raining devastation for miles around. A pro golf star's plane goes down, shrouded in mystery. 4 vehicles plunge into a river as a bridge collapses in the darkness of night. And the worst dam failure of the 19th century annihilates an entire town. Now, engineering disasters on Modern Marvels. Just 10 miles outside the city of Las Vegas lies the suburb of Henderson, Nevada. On May 4th, 1988, this small community changed forever. 3 miles from town, 2 major explosions. The older private jet models were not equipped with an automatic pressurization system that activates as soon as a loss of cabin pressure is detected. Unlike the primary pressurization system, which uses compressed air from the engine, the emergency system relies on oxygen from a reserve tank, commonly found in the nose of the plane. Not having the automatic system makes the routine pre-flight check of oxygen systems that much more vital.
Prior to any flight, the oxygen system should be checked out thoroughly because it is your lifeline in the event of an emergency depressurization. So prior to any flight, the crew should check the oxygen mask that is flowing. Here's the emergency position. You can hear the mask. And they should put the mask on and breathe.
All small jet aircraft designed after 1969 are equipped with an automatic emergency pressurization system. The Learjet in question was designed earlier. Since the older models are still flying, the NTSB has suggested the FAA require retrofitting them with the automatic system.
This accident was a particular concern to the safety board and I think to the air taxi operators because this particular corner of the industry is growing almost exponentially.
Although the FAA acknowledges that the presence of an automatic pressurization system would enhance safety, it has not implemented this proposal.